It builds on some knowledge they did in that course that Murray pointed out before, the Sally Brooker runs about ligands. They do ligands. It was seen as a development of synthetic techniques that they developed in the Cobalt lab, the lab before. So we were taking them a bit further with this stuff and showing them what they could do with that sort of lab. And it was a chance to actually do an investigation, rather than just making a set of crystals and saying, oh, it's blue, or whatever the colour is, yellow. They're going to do something with it. They're actually going to analyse it and use the knowledge they got from one of the modules about the techniques, spectroscopic techniques, and use that knowledge to... Okay, so those of you who don't know, shift base is basically a substitute imine. It's got that group in it, and it's formed in a reaction between an aldehyde or ketone and a primary amine. I found that out last week. The aldehyde we used was salicylaldehyde. We gave them two unlabeled, so they had they basically chose one, but they didn't know which one they chose, and that was important. Either diaminoethane or diaminopropane, and they made those shift bases that were there. They then formed a ligand with copper with them, and did an analysis on it. They had two possible bases. The results would look something like that. They wouldn't know what molecule they had, but they'd get a microanalysis. They'd run themselves an infrared Nugel null, which first-year students don't normally do that sort of thing. They'd be provided with an NMR, and they'd run themselves a UV-vis, and they'd also find out the melting point. And then they'd put all that data together, and then they would have to report back as part of the report process which amine did they have, by looking at this data, working out which data, particularly from the NMR and the infrared. And also they had the same data from the ligand, so they could see the difference, what happened when the ligand goes in. The H's come off, you get a ligand forming, you can see loss of hydrogen bonding on the spectrum. As spectroscopists, I loved it, because I could actually sit down and look at the infrared spectrum and say to them, look, this spectrum is changing because in this way, because the force constant's changed, the hydrogen bonding's got whatever was going on. And they actually took a real interest in that, even though they didn't particularly need to know it. Okay. So it was really good. So you can see there's an investigative element, that investigative element we wanted to bring in is in there. What do they think about it? Okay. Very basically, the question was, what's your favourite lab, what's your least favourite lab? So it's a numbers thing. I suppose I need to rush a little bit, but the one thing that's important in here, that this again sort of supports what people have been saying. The Boyle's Law lab, where they do lots of maths and measuring things, they really don't like that. Okay, it really isn't liked. A few of them liked it because it was short, sharp, simple, and they knew what they're doing, but most of them didn't like it. The aspirin one was a nice, easy lab. No negative comments, partly because we think so nothing goes wrong with it, it's just a lab that happens. Spectroscopy, again, they do a lot of calculations about the energy of the photons and things. Didn't like maths. Comments about these two, both of them. This isn't chemistry, this is physics. If I wanted to do this course, I'd be doing a physics major. Okay? Conducting polymers, they quite liked it. Shift space is a very interesting one. It's got a lot of polarized opinion, hugely. A lot of students really liked it because it was a complete investigation. A lot of students didn't like it because it was tied up with that full lab report and it was seen as a huge amount of work. And that was something that came out. Another thing that came out that was very interesting on these comments was students don't like downtime. They go into a lab, they want to be busy all the time they're there. They don't like sitting around for half an hour growing your polypyrrole. These complaints in here, every single one of them, not many of them, but they were all about how long it took to about half an hour. All the comments, most 90% of the comments on the shift base, the negative comments, are about the time it took them to run their infrared spectrum, the time it took them to get onto the instrument to run their ultraviolet. And that's something we can deal with. But the lab itself, they actually like. The final one, the reports. Very interesting. Lab reports were seen as a chance to work it out at a slower pace. They could work at their own pace. They didn't have to finish and do an exit test and rush. They could go away, they could look at the notes, they could work out what the hell was going on. And that gave them a real chance to take a breath and work out what was going on. A lot of them recognised it was a skill they needed. A lot of the chem majors recognised it was something that when they go on to chemistry, they need to have that skill. Many students preferred exit tests, but they prefer them because short, sharp, sweet, the lab's finished, gone, no homework, no extra work commitment. But they still would say they learned more from the lab reports than they do from the exit tests, which I think is an important thing. A lot of them had no preference, but they liked the balance. This is really mature. They actually recognised that each method tested different types of knowledge. So the students are actually aware of the fact that exit tests test a certain type of knowledge, lab reports test something, and they can appreciate the difference between them, which is, they're not educationalists. They've picked that up themselves. And finally, what can we do? Well, I'll rush through these. We've ticked them all. I think we've ticked them all. Some of them were better than others, but we've definitely gone a long way along the way. Future work, maybe we need to change the Boyle's Law lab and spectroscopy for a better delivery. Maybe not change what's in it, but change the way we're delivering to them. What are we actually doing? More investigations at the aspirin analysis lab. I will cry out to go back to something. That's something I should have said. The aspirin analysis lab is actually a lower level skill than you guys are doing at high school with your investigation 3.1. But that wouldn't qualify for an 3.1 investigation. It's too simple. It's how much aspirin's in it. There is no control of anything, no patterns. Colloid lab, we've got a nice little one with silver nanocrystals we're going to try. And finally, I'd just like to thank Richard. Sitting over there is a student who has patients who took us through. Dave Larson for letting us mess around with his course because he was the course coordinator and he took a risk. We weren't going to completely screw things up. And the chemistry department for providing Richard with some money for a summer scholarship to do this. Thank you.